What are we doing today? Okay, what are we doing today is we're gonna set up rate limiting for our API, for our alt text project. So if you're new here or you haven't been following along, I've been working on building this little tool for myself on stream that will help me generate alt text for my social posts. And I've had no less than 2 people tell me this is a overly simple use case and that I should just use the Claude or ChatGPT app, which is, I mean, everyone's entitled to their opinion, but this tool is specifically designed to solve my problem. So, you know, I think it'll be useful. I think I'll get a lot of use out of it. Not everybody agrees with me. That's okay. But we have tests. We have our endpoint that generates the alt text. We have a few to-do items like, we have a few to-dos around, find grep to do. We have a few, like we have a to-do around file validation, like the size of the file validation we need to take care of. There's some to-dos around like specific provider implementations, but I'm going to kind of ignore these for now because I'd like to just get to a point where we can actually use this thing from a client and we can come back and fill in the gaps when we'll implement some other providers beyond Gemini. So, but today what I want to do is I want to get rate limiting in place, because once that's in place, I'm comfortable then getting this Dockerized and getting this deployed somewhere. So how do you add rate limiting to a minimal API? So in the past, like .NET 7 and before, like the very first API I built with .NET, they did not have a built-in rate limiter, if I remember right. So let's go minimal API rate limiting. But now they do. So yeah. Here we go. Here's the announcement. I think this was .NET 7. Yeah, .NET 7. So in .NET 7, they introduced support for rate limiting just out of the box. Before, there was a third-party app. There was a third-party app that I used. I bet I can find it on my GitHub. There was, I can't remember the name of it. Criminal. Yeah, this was one of the first APIs I built in .NET. I think this is .NET 7. I think this may have been .NET 6 originally, and I've upgraded over the years. But there's a package in here. Let's see if I can find it. This ASP Net Core Rate Limit. This was like a third-party package that people used to use to do rate limiting. So NuGet. Yeah. So this was a third-party package, but now there's built-in support. You can do concurrency limits. You can do it based on a token bucket, fixed window. You can do a sliding window, and they kind of explain this all in this announcement post. But there's also good documentation on it too. So let's search for minimal API rate limiting. There should be some docs. Here we go. Here's some docs. So what we want to implement, or what I want to implement, is I want to implement a fixed window limiter, and I want it to just be global. I just want a global. I don't want to specify this on a route basis. But I also want, so you can have rate limits, right? But then if you do this, like if you do this right here that they're showing in the docs, that makes it global for your whole application. Or I guess I should say, that makes it, when you apply that policy to an endpoint, that's a global policy. And so that fixed rate limit is not partitioned amongst your users, right? So you can create partitioned rate limiters, which then say, okay, you know, like if we were doing it based on user, we'd be able to say, user 1 can make 10 requests an hour. User 2 can make 10 requests an hour, versus kind of that non-partitioned, which would be everyone can only make 10 requests an hour. right? So if let's say like 2 users each make 5 requests within an hour period, they both get rate limited, and I don't want that. So, and I also don't have identity as part of this API because I don't need it. So we can't use identity, so we're going to use IP addresses. And I think they have an example here that specifically shows that. And I've implemented this before on another API. Yeah, so here's an example of like the partition limiter, right? This is global, so this is being applied to all your routes. I basically want to do this, but I don't want to do it on the user agent. I want to do it on the IP address. I know there's an example in here somewhere. Yeah, I don't see it. Okay, let's go to one of my old projects. I know for sure I implemented this on one of my projects. Let's see. I think I implemented it in Onyx Graph. Oh, no, come on, program. Yeah, here we go. This is what we want to do. So let me put this on the other screen. And let's get to work implementing this so that I'll just reference it from this other screen. But I want to be able to reference it a little bit easier than that. Sometimes I have too many windows. Too many windows. Anybody else have that problem? Too many tabs, too many windows? All right, so to implement rate limiting for a minimal API, this is kind of my approach to implement a global limiter that'll affect your whole API. It's not going to be per route specific, but this is kind of where I usually start. And so what you're going to do is the first thing is you're going to probably want to make a check to see if you want to actually add the rate limiting based on whether it's in production or not. So that's usually what I do. So, because there's not really a sense in having this enabled in a development environment. So I'll usually say if app is environment.is production. I don't want the exception handler there, Copilot. I want to say app.use rate limiter, like that. Which is great, but we obviously don't have any rate limiting configured or defined. We don't have any policies or anything like that. So now what we're going to do is on the app up above, on our app builder, and specifically on our builder's services, we're going to invoke a method called builder.services.add_rate_limiter, just like this. And then that's going to take a lambda, which has some configuration that we can do. So let's make our lambda and fix our formatting a little bit here. And we are going to set this to o.global_limiter. And then we are going to call, not new rate limit options, we're going to call partitioned rate limiter. And we are going to say create. And I think I'm missing a namespace, so let me add that real quick. Using System.Thread.RateLimiting. And then we're going to call create our limiter. And here we're going to define it. So this takes a lambda as well, which is going to be an HTTP context. And actually, let's just do CTX for brevity. And then we have to return something from here. And what we're going to return is we are going to return our limiter. So we'll say rate limit partition dot get fixed window limiter. So this is going to be a window that's basically a certain amount of time. You can make this many requests. But obviously we want to partition this. So we need to first define a partition key. Partition key. And so let's just say for now we'll just put global, right? Which means everyone's going to end up getting put into that partition, but we're going to actually turn that into an IP address in a second. Then we're going to have a factory, and that factory is going to take a partition, and that partition, what is that type? That partition is a string, so that is going to be our new fixed window rate limiter, and then we need to define some options for that. Whoops. Not rate limiter, we want rate limiter options, like that. And then we're gonna come down here and we're gonna define our options. So in this case, I'm gonna say my permit limit is, let's just set it to something real low so we can test it. Let's say it's like 1. And then let's set the queue limit. This is how many it will queue up for us. We'll set that to 0 because I don't want it to do any. And then let's set the time span so that we can test it. Let's set the time span for kind of an egregiously long time. Let's just say time span dot from minutes is 5 or something like that. Oh, sorry, it's not time span, it's window like this. And it wants us to use an expression body, which is fine, we can do that. Okay, we can do that same thing up here. But now I'm gonna want to mess with the formatting here to make this a little bit more readable. So O goes to a global rate limiter. It's going to be set to a partitioned limiter, and that's going to be created from a context like that. We can make this static. We can make this static. And let's move that in there. And then this wants actual types. So this is actually going to require 2 types, which is going to be HTTP context and string. Okay, so now we'll permit so basically we're going to permit 1 request every 5 minutes. And then also let's remove our check down here for now. Let's actually remove this so that the app just always uses rate limiting. And I'm pretty sure rate limiting has to be called before the map endpoints method. I think that's an important thing they call out in the docs. Let me look back here. Use rate limiter. Let's see. Yeah, right here. It says use rate limiter must be called before use routing when rate limiting endpoint specific APIs are used. So that's just an important thing to know. If you're going to rate limit specific endpoints, the order of those method calls is important. Okay, so now what we're going to do is, should we test this real quick just to make sure it is actually rate limiting? We haven't got the IP address right yet, which we can use the context to do that, to get our IP address. But right now, everyone's just getting put in the same bucket. So while this is a partitioned rate limiter, it's essentially not, because the key is going to be the same for everybody. So let's write that out. And let's go ahead and test this. So let's open up a new console window here. We need to disable readline. Let's cd into software projects, altgen again. We'll say .NET run. Source, altgen API, and we need to give it a project flag. Like that. And so hopefully this starts up okay. And then we need to open probably Postman, right? We can do some testing here. It's fine. Oh, I hear my kids coming home from school. Forgive me if there's a lot of noise in the background for a minute and a few minutes. Let's see. So let's open a new Postman tab here. And we're going to make a post. We're going to make it to HTTP endpoint localhost 7297 at the generate endpoint. And then our body is going to be form data. And we're going to need LLM. I forget what our request needs to look like. Yeah, I wrote the API and I don't know how to use it. This is a common thing. So we need a provider key. We need a provider key, a provider key, and a file. So I'm not gonna I'm gonna give it a bad key, but we will set provider to Gemini. We'll set provider key to something that's fake. Hey guys. And then we'll turn this into a file, and this key will be file. And we'll give it test image. Okay, so now we should do, this should return a 400. Oh no, returned a 500. Huh. Wonder why. But now if I send another request, I think I should get rate limited. Yeah. So it's 503, means it's unavailable, right? But I think we can change that. I think that's the default, so we can actually change. We can actually change that. But it is working. The rate limiting is working. So let's shut down the API real quick. And let's go back over here to our program. And we can actually define some additional pieces on this options. So now we're going to convert this to a not lambda, or I guess to a non-expression body lambda. So go here, tab all that in. Tab all that in. So now what we're going to do is we're going to come over here and we're going to say, okay, O dot rejection status code is going to be status code 429, and then we'll say O dot on rejected. And so this is a property that you can set to basically tell your API how to respond when the rate limit's hit. So we're going to say static context equals, yeah, that Copilot, that should work. And then we need to return a completed task. Return value task completed. Oh, and then we also need to say, instead of doing it like that, we need to say if context.lease.try get metadata, if that has a metadata name dot retry after, then we will outbar the retry after, and we'll add it to our context. But this is not an HTTP context. We need to say context.http context dot response, like that. And then this is going to be x. We're going to do x retry after. And then this is going to be retry after. We'll say bar retry date equals date time dot UTC now. And this should just be retry like that. And then this needs to be converted to a string. And specifically, we want to use the O format. And if I remember right, the O format let's see. What doesn't it like about this? With what? What does it want? Culture info dot invariant. Invariant culture. There we go. That's a little long. Let me put these on separate lines. So now we have a retry after header being appended to our response, and now we're also using 429 instead of instead of 503. Okay. Whoops. Yep. And we need to add this here, and these are off file tab. Okay, so let's restart our API. Okay, let's go back to Postman now. This is going to give me a 500. But if I send another request, it should give me 429. 429. 429. Okay, it's not. So why is it not? What did I mess up? Use rate limiter. Oh, it's not even reaching that piece of code. It's tripping up on something else. Timespan.format. Input string was not in a correct format. That should be right. ToString. Let me look. ToString. C# invariant. Oh, this because I don't want to use the time span. I want to use retry date. So shut that down. Start it back up. Go back to Postman. We'll save this. Well, we don't need to save it. We'll just resend it. it'll fail because something's going on with my Gemini call. Then I'll send this again, and it gives me 429. So now I've rate limited. And then I should have a header with the date or the time at which we should be able to retry and get a successful request, which is about 5 minutes from when I just made my request, which is awesome. Very cool. However, we still have this problem where we're using this global, this is hard to demonstrate at the moment, but we have this global key. So if I hit the API twice in these 5 minutes, I've essentially rate limited it for everybody, because now everyone's going to get put in that global bucket, and we don't want that. So what we need to do is we need to get the IP address for the person making the request and use that as our partition key. And so the way we're going to do this is we're going to use our context. So we'll say context dot HTTP context. And the first thing we're going to look for is we're going to look for the X forwarded for, right? Because this is going to run behind proxy when I deploy this. So the first thing I'll look for is the X forwarded for header. Yeah, X forwarded for. And then if that's not there, we want to look for the remote IP address. So we'll say context dot, oh, also this is not the right context. Then we'll say, if that's not true, let me put this on the new line. If that's not true, then we'll say context remote IP address. And if that's still not true, we will say unknown. And if you're an unknown person, you're going to get bucketed with all the unknown people, unfortunately. Oh, and this doesn't need, this is an HTTP context. This is a direct HTTP context. So we'll say HTTP context. Oh, and this needs to be .toString. This is deference, so we need to do an optional chaining. And then this is not literal unknown, but a string unknown. And that'll just be our global bucket if for whatever reason we can't resolve these two. It would be weird if we can't resolve either of these IP addresses. So now our rate limiting should work the same. So if we start up our API again, we call it, it should fail, which we know it's been failing. I don't know why it's failing, but now it should send another request and it should rate limit us now. And it should just keep rate limiting us for, you know, until that retry time expires. Okay, cool. So now we have rate limiting set up, which is good. That was like the next thing I really wanted to get accomplished. Oh, you know why this is failing? You know why my requests are failing? Is because I it's most likely because I'm giving it a bogus key. So that's why. I should probably. Why is my API having trouble shutting down? There we go. I should probably. Like, it would be helpful if if somebody sends a bad key and the Gemini API responds with the bad key, it would probably be helpful to pass that info along to them so that they know. So I'm going to add that as a to-do. But before I do that, so that is at a high level, right? Very quick and dirty. That's how I set up rate limiting for minimal APIs. And I just use the built-in System.Threading.RateLimit package. And this is basically generally how I set it up. Now, there's all kinds of different things you can do with rate limiting, like we talked about, where there's different types of rate limiters. There's different, yeah. So there's different types of rate limiters. You can rate limit per route. You can add multiple different types of rate limiting policies to your application and apply those to different endpoints so that different endpoints have different rate limiting. But this is what I use now for minimal APIs, and this is how I set it up. This is kind of the starter point of where I set it up. And so you could theoretically, you could have a situation where you have kind of a global limit on your API, say like 10,000 requests an hour, but then maybe for even more sensitive endpoints, maybe like logging in, resetting passwords, that sort of thing, you could set a more granular API or a more granular rate limit to maybe like only be able to, you know, attempt to log in 5 times within a 1 minute thing, something like that. So you can get really granular and make this work however you need it to work. But this is how I do it. I hope it helps. Hope you'll be able to put that to use.